Solve the equation e raised to the 2d, subtract 4 times e raised to the d is equal to 45. All right, so this equation, to me, it looks like it's quadratic in form. And that might not be obvious right away, but we'll use it. If we use a substitution, it becomes easier. So what I know is that if you think of your rules for exponents, e to the d squared, if you remember your rules for exponents, if I raise a power to a power, I multiply the exponents. And so that's e to the 2d. So if I let x equal e to the d, then x squared is equal to e to the 2d. So then this equation, after a substitution, becomes x squared minus 4x equals 45. And I know how to solve that equation. Let's see, that's the same as x squared minus 4x minus 45 equals 0. And so this will factor, or you can apply the quadratic formula, whatever's better for you. I'll go ahead and factor. So this factors as x plus 5 by x minus 9 is 0. So then x plus 5 is 0, which implies that x equals negative 5, or x minus 9 equals 0, which implies that x equals 9. But we have to be careful here. We aren't done, because our original equation was in terms of the variable d. We made a substitution to turn the equation into something in terms of x, but now we have to go back and solve for d. So x equals negative 5 or x equals 9. Okay, but remember that we said that x was e to the d. So then e to the d is negative 5 or e to the d is 9. All right, d is my variable. And remember, e is just that exponential constant, that Euler number. It's 2.718 approximately. So here I'm saying e to some power is negative 5, and that's impossible. E to a power is never negative. E to a power is always greater than 0. E to a power is always positive. So e to the d is negative 5. That's useless. That doesn't give us any solutions. I can't solve it in terms of d. Now, the other equation, e to the d equals 9, we can solve, and let's convert that to its logarithmic form. So then d would equal the natural log of 9. Now, if you said, okay, well, if you didn't see that, and you had gone with that first equation and you converted it to its logarithmic form, then you would have said, okay, well then d is the natural log of negative 5. Now, if you bring up your calculator and you try and calculate that number, so let's see, let's clear this old stuff and let's type in negative 5, and let's calculate the natural log, and it gives us an invalid input. So your calculator will probably give you some sort of an error if you try to calculate the natural log of a negative number, or in fact, any logarithm base of a negative number. Now, if we needed to, we can approximate the natural log of 9. It's 2.1972. Let me make sure I copied that right. Yeah. So this gives us one solution. There's one solution to the equation, which is exactly negative 9. This gives us one solution of the equation, which is exactly the natural log of 9, or approximately 2.1972.